Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Hero to Superhero series on coding artificial neural network. Alright guys, so we have covered quite a bit, right? In the previous lesson, I did show you how to train an artificial neural network. Now, the important piece is prediction, right? How are we going to predict using a predefined set of data, and then later on I will show you how to load the data from a CSV file or Excel or any images and stuff like that. There are different formats of data which we can load and train the neural network. For now, let's move on to prediction. I'll open up my IDE and this is the code for the entire prediction stuff. So basically, we are calculating the neuron activation for an input, which you know already. This is the particular section. After importing the library called math, right, and the random, of course, the seed data, and then we are moving on to the neuron activation function, and then we are moving into the forward propagation of input layer to the output layer of the neural network. That's this code. And then we make the prediction with a network, which is this particular section, which is very important, right? So what this does, so basically making a prediction with a trained neural network is easy enough. It's pretty easy, just about 2-3 lines of code, as you can see. We have already seen how to forward propagate an input pattern to get an output. So this is all we need to do to make a prediction. It's as simple as that, right? But we can also use the output values themselves directly as a probability of a pattern belonging to each output class, right? So it may be more useful to run this output back into the crisp class prediction. We can also do this by selecting the class value with basically, kind of larger probability. This is also called the argmax function, argmax function. This is one of the predefined functions within some of the bunches of algorithms, right? So this particular function in this code, as you can see, which is called the predict is a user defined function. We can build it that implements this particular procedure. It returns the index in the network output that has the largest probability. So assuming that the class values have been converted into integers, basically the binary integers starting at 0 value, right? So basically we can put together our entire set of code, what you had seen in the previous lessons, which I had done here. You can see it on my IDE for forward propagation input with our small contrived data set to test making the predictions with an already trained network. We already trained the network in the previous lesson, right? So this particular example is a hard coding a network trained from the previous step. So it's as simple as that. When we run this code, basically after we run this as an example, the expected output for each record in the training data set should be, by default, it should be 100% accuracy. For example, expected is equal to 0 and got is equal to 0, right? And then expected equal to 1 and got equal to 1. So it's as simple as that. So now let's see what happens. Let's try to run this code and see, based on these weights what we defined, we should get exactly the precise output, like expected equal to 0. That means output what we got should be 0, or if it is 1, it should be 1. Let's run this code. Let me just run it. I hope it works. Wow, perfect. My system is pretty fast to run this entire neural network and look at the prediction. Look at it, guys. Expected equal to 1, got equal to 1. Expected 1, got 1. Expected 1, got 1. Wow. So this looks to be fabulous, isn't it? So guys, go ahead and pick up this code from my GitHub repository and combine the entire section what you learned so far and try to run this prediction and see what happens in your system. You need a pretty good laptop or a desktop machine. You might use, in case if you are using i3 or i5, guys, it's going to take quite a long. I would suggest go for a pretty good machine learning or deep learning ready system with a GPU, NVIDIA GPU and stuff like that. In case if you cannot, you might still try an i5 machine or any of the low end i7 machine. It should work. This is all working on Windows. If you guys are from Linux background, definitely Linux machines are much faster, but you can give a try. Anyways, I'm not going to recommend from hardware perspective because I'm used to deploying AI not only on the edge devices, including Arduino, Raspberry Pi, Jetson Nano, or any of the desktops and laptops. So, anyways, I will see you soon. Goodbye.